And hello and welcome back to our session on OneClass. My name is Joey. I'm going to be your Algebra 1 teacher for today, for this morning. So just a little bit about me and a little bit of background about myself. Again, my name is Joey. I'm currently a teacher candidate at York University, so specializing in teaching in the intermediate senior division, specifically in topics such as chemistry and science, and as well as music. However, I'm also planning to get my math teachable further down the road. So again, here at OneClass, what we're aiming to do and what our goal is, our goal is to try to provide online accessible lessons for topics such as chemistry and mathematics at the secondary level. And what we're doing is we're hopefully preparing students for kind of the days to come. So amidst the COVID-19 with the school closures as well, this provides a unique opportunity for OneClass for us to kind of share these videos with you all, make them accessible so that parents and guardians may choose to use OneClass as a resource for them to help educate their children at home. So hopefully you find these videos useful, and without further ado, let's pick off where we kind of left off. Pick up where we left off for last session. So what we're doing today is let's just review. If you remember from last session, we did a lot of work on absolute value equations. So what this was if I were to review absolute value equations, then maybe I'll do a question for you. Let's do 14. So remember, with absolute value equations, what you can sometimes get is you can sometimes get more than one answer for your problem, and we had to divide this in it. We had to check our algebraic equation in a case-by-case scenario. So let's do number 14 as a review, and then we'll move on to today's lesson on radical equations and hopefully rational equations as well. What we have here is we have 4, and then we have the absolute value of n plus 8, and then equals 56. So we have this kind of equation here, and what we're doing is, again, what we're trying to do with all equations, we're trying to isolate for this n value, right? So if we isolate for this n value, what are we going to get? So remember, you can think of the absolute value bar as also imaginary brackets or parentheses. So what that means is we can kind of put, this is my imaginary parenthesis on these sides here, right? So what am I going to do first to isolate for this n is I'm going to have to get rid of this 4. So I'm going to divide both sides by 4. So I'm going to get here n plus 8. If I divide this both sides by 4, this 4 cancels out, and I'll have 56 divided by 4 on this side. So n plus 8 equals, I believe that's 16. 16 times 4 is 56. Just check that. No, 16 times, no, it's not 16 times 4. 56 divided by 4 is 14. Sorry, 14. So we have 14 here. So 14, yeah, 56 divided by 4 is 14. And what we're going to do is we are going to now divide this into case-by-case scenario, right? Remember, the moment we try to move the plus 8 out of the bracket side, or sorry, the absolute value bar side, it can either be positive 8 or negative 8, right? So let's do our first case where it's where we subtract both sides by negative 8. So we have n plus 8. This would be minus 8 equals 14 minus 8, right? That's what we're doing. The change here, actually maybe we'll do it in blue. The change here is in blue, right? So this is negative 8. So I'm subtracting both sides by negative 8 to get rid of that positive 8 in the bracket. This should be negative 8, sorry. Negative 8. And then so we're just left with here, these two cancel out. So we're left with the absolute value of n equals 14 minus 8, here is 6. And then as we know here, anything in the absolute value bar, if it was a positive number or a negative number in the absolute value bar, it's going to get canceled out. So what happens here is I'm going to get two cases. So n here would equal plus or minus 6. And then we'd have to check our answer. So let's check our answer first with this function here. I'll check it with this equation here. With here. So let's sub in positive 6 first. So this is again, I'll do my check in blue here. So let's check positive 6 first. So if n equal positive 6, then I would have here, this is absolute value of n plus 8 equals 14, right? So if n was positive 6, so 6 plus 8 equals 14. 6 plus 8 here is 14. So absolute value of 14 equals 14. And obviously 14 equals 14. So we're good with that one. So which means positive 6 is indeed an answer. And then now we're going to check negative 6. So let's check what if, I'll do this in red. What if n was negative 6? So we'll have here, this is n plus 8 equals 14. And we're subbing in negative 6 for n here. So this would be negative 6 plus 8 equals 14. Negative 6 plus 8 is positive 2. So 2 equals 14. And here we have 2 equals 14, which is, in this case, it's incorrect, right? This does not satisfy this equation here. So negative 6 is not an answer, which means my only answer here is just positive 6. I can erase this. Actually, I'll erase all of this and say n has to only equal 6 here. Erase this. And then what we're gonna have to do is we're gonna have to check our the other case, right? We're gonna check our other case. I don't know why it's not erasing. Okay, cool. We're gonna check our other case. So let me bring this back up. So we're gonna have to check our other case, right? So we have here, we set negative on both sides. Remember, if we took out the positive 8 from the absolute value, we would have to check both cases. So we have, instead of this, we would have n plus 8, and we have to add 8 to both sides, right? Because what if this was negative? So let's do that. Let's add 8 equals, this would equal 14 plus 8, right? And then what we have, these two cancel out. And then, because we're assuming this here is a negative number, right? So that's why we're adding 8 to both sides here. And then what we're going to do is we are going to, I have n here, absolute value of n equals 14 plus 8 here is 22. And then n in this case would equal positive or negative 22, right? So how would we do this problem? So again, let's sub this back into our first equation here. And then check, right? So we're checking, let's check first. Check n equals positive 22. So if n was positive 22, I would have here, this n would be 22. This n here would be 22. So I would plug in 22 plus 8 equals 14. 22 plus 8 is 30 equals 14. Absolute value of 30 is simply just 30 equals 14, which means this is my wrong answer. So I don't have a positive 22, but do I have a negative 22? So let's check that. So what if n equals negative 22? So negative 22, this would be plus 8 equals 14. Sorry, the absolute value of that. Negative 22 plus 8 is negative 14 equals 14. Absolute value of that is simply just 14 gets rid of that negative, right? So that's going to be our correct answer. So in this case, it would be not positive, but only negative 22. So negative 22 and positive 6 will be our correct answer for this problem. So again, just a little review on absolute value equations. We have to break them down into two parts, and then with this one especially, we're doing both operations, right? Usually what we do, if we didn't have the absolute value, we would just simply subtract 8. We're doing the opposite operation, right? But we have to do the opposite operation for one side and the same operation on the other side we're going to, because we want to find out if this is if the inside bracket was indeed negative or not. So that's what we're doing. That's why we're doing the same operation. So again, we have two answers, and both of these again satisfy this equation here. So that was absolute value equations. That's what we did last week. So what we're going to move on to this concept of radical equations. And when we talk about radical equations, so let's make a new topic here. This is radical equations. So when we're talking about radical equations, what they are is that they are these square roots or cube roots. So let's say, so in this case, if I had something like the square root of 4, we would say this as, this is the square root of 4. So square root denotes this kind of little hat thing, and the 4 is just simply whatever is inside, right? So again, we're familiar with square roots, and we can solve for these actually. Square root of 4, in this case is 2, right? Because we have, the square root of something is basically, I'm splitting up this number 4, into 2 same factors. And in this case, 2 times 2 equals 4, right? Oh, sorry. I keep doing that. So in this case, this will equal 4. So the square root of 4 is simply just 2 here, right? So that's a little review. If I had, for example, a square root of x, I'm going to have this is the square root of x, right? And then I could solve for this, but I don't know what my x is in this case, so I can't solve for this. This does not give me a number or a variable. It's just square root of x, right? And then what if we had something like the what if we did something like this? So this would be, instead of square root, I see this 3 here outside the hat, right? This would be a cubed root. So for these ones, they have an imaginary 2 here, and this denotes a square root. But in reality, we actually don't put the 2 here, because the hat itself, this hat itself, signifies that's already a square root. If it was a hat with a number, then it would specify a power root, or in this case, it's the cubed root. So I'm going to say here, this is the cubed root of, and then whatever is inside is 8, right? So in this case, it would be, I have 3 of the same numbers multiplied to 8. So what 3 numbers, and they have to be the same number multiplied to 8. So in this case, it would be, inferring this would be 2 times 2 times 2, right? 2 times 2 is 4, times 2 is 8, 8 equals 8, right? So in this case, the cubed root of 8 here is 2. So again, these are all your functions. If you have a calculator with you, can actually plug these into your calculator, right? So that's fine. So this is just a little review of that. But when we have a radical equation, so let's do number 1. What happens if we use it in an equation? So if we have number 1, we have the square root of x equals 10. So how would I get rid of the square root sign here, so I can solve for my x? So I remember, if I was adding something from one side, so recall that it was x, and what if it was x plus 3 equals 10? What would I have to do to get rid of the positive 3 in this case? I would have to do the opposite operation, right? So instead of positive, it would be negative, right? So I just have to subtract both sides by 3, right? So in this case, this cancels out. This x equals 10 minus 3. Here's 7. That's my answer, right? But what about this problem here? How do I do the opposite? What's the opposite operation for my square root? So opposite operation of square root is I'm raising it to the exponent. So what I mean by that is if I did, so I'm going to show you here. So x square root x, I would have to square both sides. If I have a square root, the opposite operation is squaring. So just taking the exponent to 2, right? So this is a square root. And then I'm going to take it to the power of 2. Take both sides to the power of 2. So in this case, here I would have, I'm squaring the number squared. So this here is, then what that does is going to cancel out this square root. So this square root and this 2 cancels out. So I'm left with 2x equals, and then 10 squared, right? And we can rewrite this as 10 squared is 10 times 10, right? So this 2 denotes that it's being multiplied by itself twice, right? So 10 times 10, and then obviously x equals 10 times 10 here is 100, right? So, and that's going to be our answer for number 1. So again, when we're doing these problems, what we have to figure out is the opposite operation. So therefore, we can write here, the opposite operation of square root is just squaring squared, right? It's just raising it, right, to an exponent. So this would be exponent, right? And then if I did it with a cubed root, so if it was the same thing, opposite operation of a cubed root, I would cube the number, right? The opposite operation would be the cubing. So for example, if I had it was a cube root of x equals 2, what I'm going to have to do is I'm going to have to take the exponent of both sides by 3, right? I want these 3 to cancel out, which means I have to take this power to the, I would have to take 2 to the power of 3, or 2 cubed. And 2 cubed is simply 2 times 2 times 2, right? Which is 8, and that's going to be my answer, right? So x equals 8 in this case. So the important thing here to note is that just you have to know this rule, right? Opposite operation of square root is exponents. So again, as we're squaring it, and then if it was cubed root, it would be a cubed. If it was the fourth root, it would be to the power of 4, and etc. etc. So that's how we solve for radical equations. So let's do let's go down and do a couple of these problems, and we have actually 2 sets of problems. We have, this is the easy problem, and then we have the harder problem. So I'm hoping we can get through some of the easy ones and some of the hard ones today. So let's do every other one. So let's do number 5. Let's do every other one in the left column. Sorry, I'm going to specify that. So 5 here is, this is root n equals 9. So maybe take a minute, if you're in the chat, maybe wave hi, and what you're going to do is you're going to think about, how would I get rid of the square root so I can isolate from my variables. Take a moment and do that, and then we'll take it up together. So what is our first operation here? What are we trying to do first? So remember, the square root of n, I want to do the opposite operation to get rid of the square root, right? So the opposite operation is squaring, or taking the exponent to 2, right? So I'm going to square both sides, and that's the operation to get rid of the square root. That's the opposite operation of the square root, right? So which means that this square root and this square I get rid of that on this side, and I'm left with n equals 9 squared, right? 9 squared, I can rewrite that as 9 times 9, which equals, n in this case would equal, and 9 times 9 here is 81, and that's going to be my answer for number 5 here, n equals 81. So that was pretty easy. Let's do 9 here. 9's a bit harder. And because there's more things you have to do, it's a multi-step problem here. So 9 here is negative 8 plus the square root of 5a minus 5 equals negative 3. So again, this one's a little bit trickier actually, because this is a multi-step problem. So again, what are we doing first? And remember, keep in mind, whenever we're isolating for variables, we are using reverse order of PEMDAS, right? So remember this concept of order of operations. This is PEMDAS, and whenever we're isolating variables, we use the opposite order. So you have to read this backwards. So in this case, we would do exponents are actually, or square roots are under exponents. So this is actually very, very low on the priority list when we're isolating. So we do that last, right? So that means we're going to do subtraction first, right? So in this case, if I have this minus 8 on the side, it's minus 8 plus square root of 5a minus 5 equals negative 3, right? What am I going to get rid of first? I'm going to get rid of this negative 8. And if I want to get rid of negative 8, I'm taking the opposite operation, which is positive 8 on both sides. I'm adding 8 to both sides. So adding to both sides, the left side, this will just cancel out. So I would just simply have square root of 5a minus 5 equals, and then I have negative 3 plus 8, right? And then I can solve for this. 5a minus 5 equals minus 3 plus 8 in this case is positive 5. And then what do we have to do next? Well, in this case, we actually have to we can't do the subtraction here first. What we're going to have to do is we have to do the square root first. And why do we have to do the square root first? Is because this square root applies to everything here. So you can think of it as a bracket. The square root this square root affects the entire term of 5a minus 5. It affects this entire term, right? So because there's imaginary brackets around this, exponents go first and then p, right, which is parentheses. So in this case, we would do the exponent first. So I'm going to, again, this opposite operation of square root is square, so I'm square both sides. So what I'm left with is here 5a minus 5 equals 5 squared, right? Because the square root and this exponent is going to cancel out on this left side here. So that's fine. That's dandy. 5 squared, we know 5 times 5 is 25, right? So 5a minus 5, equals is 25. And then what we're going to do is, again, we're doing the same thing, right? PEMDAS states that we do subtraction first, right? Opposite of PEMDAS is subtraction first. So we have 5a, I'm doing the opposite operation on both sides. So it's plus 5 to both sides, right? So this would be 25 plus 5. And then we have 5a, 25 plus 5 here is 30. And then our last step here is 30. Our last step here is we have to divide both sides by 5, right? Remember, 5 times a opposite operation is division. So we're just dividing both sides by 5. So a in this case would equal, because it's canceled out, would be 30 divided by 5. A in this case would equal 6. And that's going to be our answer for this problem here. So it's a bit trickier, right? We have to do, there's a lot more things we have to do in this case. We're not simply just taking the square root first, but we have to recognize this order of PEMDAS before we started this problem here. Let's do 13, and I like this because there's a little bit of fractions here. So let's do, again, we're doing every other one on this left column. So let's do 13. And then we'll move on. So this is 10 plus, this is the square root of 10m minus 1 equals 13, right? So again, the first thing we have to do is, I'm going to extend this little guy here. So it covers it, there we go. Because the square root applies to this negative 1 as well. So again, the first thing we have to do is, again, PEMDAS states that we have to isolate the addition first, right? So if we're isolating the addition one, I'm going to have to subtract both sides by 10, right? So this would equal, here's 10m minus 1. We're not touching this term. But 13, we're going to subtract 10 to both sides, right? Because we're adding 10 to one side here. So we're going to subtract 10 to both sides to get rid of that positive 10 on the left side. So this would be 13 minus 10. And then we have the square root of 10m minus 1 equals 13 minus 10 here is 3, right? Sorry, I'm going to extend this. And then, again, I think of imaginary bracket here because we have where the square root applies to the entire term of 10m minus 1. So we would get rid of the exponents first, right? So if I want to get rid of the square root first, I'm going to have to take the exponent of 2 to the both sides, squaring both sides, right? So I'm left with here, the square root cancel out, so it's 10m minus 1 equals 3 squared, right? We know that 10m minus 1 equals 3 squared. Here's 3 times 3, which is simply just 9. And then what we're going to have to do is we are going to have to do our subtraction, right? We have to get rid of this minus sign here. If we wanted to get rid of this minus sign, we're adding both sides by 1. In this case, we have 10m equals 9 plus 1. 10m equals 10, right? And then divide both sides by 10, right, to isolate for this m here. So we have m equals 10 over 10, which means m in this case equals 1. And that's going to be our answer for number 13 here. So again, very, very simple. All we're doing is we're breaking down. This is very, very similar to the previous problem we did. All we're doing is we're breaking down this kind of function, this equation here, right? So we have, again, positive 10. We want to get rid of that first. Then we get rid of the square roots, and then we can work. And then it's simply just another multi-step equation that we've been working on for the past bit, right? So again, we're just adding little operations here and there for you to get used to and whatnot. So let's do 17. So 17 is actually kind of tricky. Like, how would we start 17? So this is square root of 3n equals the square root of 4n minus 1. So how would we do this problem? How would we do this problem? So maybe take a moment to think about this. We have a square root on both sides. So how would we get rid of a square root on both sides? What have we done in the past? Let me take a minute to think about that. Hello, YouTuber. This is Killer Revs. Hello to you too. How are you this morning? So again, what we're doing is we're taking the opposite operation here is the exponent, right? So if I have the square root of both sides, what I can do is I can square both sides. I can take the exponent to both sides. So again, how to do that? Is I'm simply taking the exponent to both sides, right? So in reality, I'm doing square root of 3n here. I'm going to square this side, and then I'm going to square this side as well, right? So that's how I would get rid. I'm doing the opposite operation both sides, right? And in this case, this is actually, it works out really nicely because what it's going to do is this square root is going to cancel with the squared, and this square root is going to cancel with the squared. So all we're left with here is simply just 3n on this side, and just simply just 4n minus 1. Now this is so much easier, working with this, because again we don't have a square root here, right? So all we have to do is we have to gather like terms, so like we were doing before. So 3n equals 4n here. I'm going to place all my variables on the left side here. So I'm going to drag 4n to this side. If I want to do that, it's going to, instead of adding 4n to both sides, I'm going to do opposite operation, which is subtracting 4n, right? So I have 3n minus 4n equals this minus 1. All I'm left with here is minus 1. 3n minus 4n is just simply negative 1n, or just negative n equals negative 1. And then I'm going to have to divide both sides by negative 1, right? So I have n here equals negative 1 divided by negative 1. And here, simply, these two cancel out. And 1 divided by 1 is 1, right? So n equals 1 will be our answer for this problem. So again, the trickiest part was the first step here, right? Where we figure out that the opposite operation of square root is squared. So we can square both sides. And in this case, it just comes up, it just falls apart, right? So that's nice here. I'm not going to do 21 here. 21 is a very, very similar problem, but I'm going to do here, maybe I'll do 23 and 25 because these might seem a little harder. So 23 and 25, and then we're going to work on the second part of the more difficult problems here. So this is 23. So the square root of this is 72 minus x equals the square root of x over 5, right? So like my similar problem from before, if I see square roots on both sides, I can simply just square both of these sides, so it cancels out the square root, right? So I can do square root of 72 minus x squared equals square root of x over 5 squared. And what that does is it's going to take apart these square roots, right? So I'm left with 72 minus x equals x over 5, and that gives us a lot easier. It's much more simpler of a problem than what we had before. So in this problem, what we have to do, 72 minus x equals x over 5. I wanna get rid of this divided over 5 here first, right? And the reason why I want to do this first is because this here is stuck to this x. I want to get this x alone, right? So if I wanted to get this x alone, I'm going to have to multiply both sides by 5 in this case. So if I'm multiplying both sides by 5, I would get, this here would be 5 times 72 minus x equals x, right? 5 times 72, let me just see my calculator for a sec. 5 times 72 in this case is 360. Sorry. 360, and then again, this is distributive property, right? What I'm doing here is distributive property. So I have this outside bracket, so this is going to go into this, and this is going to go into the negative x here, right? So again, 5 here times negative x is minus 5x equals, this simply just equals x, right? And then what I can do is I can gather some like terms here. I can move the x's to the right side in this case because I want them to be all nice and tidy on the right side. So this would be 360 equals, I have x, and then what I'm doing is I'm adding both sides by 5x, right? The opposite operation of subtraction is addition. So I'm adding both sides by 5x. So I have 360 equals x plus 5x is 6x here. And then what I'm doing is I'm dividing both sides by 6 to get rid of this x, right? So I have 360 divided by 6 equals this would just simply equal x, and then in this case it's 60 equals x, right? 360 divided by 6 here equals 60. So that x equals 60 is my final answer for this is number 23. So again, same thing, same problem approach as before. We're getting rid of the square roots first, and then we're working in the brackets, and and then we're working without the square roots because we don't really like the square roots. We want to get rid of them first. So let's do 25, and then we'll move on to some harder radical equations. Don't know if we have time to touch rational expressions, but maybe that we'll save that for Thursday, for the Thursday stream here, depending on how long we spend on the harder problems. But I can picture that we spend more time on the harder problems than on the easier ones here. This is number 25. So again, take a second to look at this problem, because this is we're getting to one of the more challenging problems here. So take a second. What do we do first? The first instinct when you see two square roots, when you see square roots on both the left side and the right side, what would you do? So take a moment to think about that. So again, my instinct here is that I want to get rid of the square root. So if I want to get rid of the square root, I do the opposite operation, which is just squaring both sides, right? So let's do that. So I have 2k plus 40 squared equals negative 16 minus 2k squared, right? And again, what it's going to do, square root goes away. Nice. And then I'm left with here is 2k, sorry. This is 2k plus 40. Sorry, give me a second. This here is, sorry, 2k plus 40. And then I have this negative 16 minus 2k. So all I'm doing now is I'm just gathering like terms, right? I have here a 2k and a negative 2k here. So I have 2k, negative 2k, and then I have some constants here, right? So all I'm doing is gathering like terms. So let me I'm working from left to right. So let me put the variables on the left side. So 2k, and then minus 2k here. I want to go on the left side, so I want to move this to this side, right? If I'm moving it, I'm doing the opposite operation of minus. So this is positive, right? So it'd be 2k plus 2k, which would equal 4k. So 2k plus 2k here. And then I'm leaving plus 40 equals negative 16. 2k plus 2k equals 4k. And then I have here, this is still plus 40 equals negative 16. And then what I'm doing here is that I'm going to move the constants to the right side, right? So this 40 is going to have to go onto this right side. When I move it to the other side, I'm doing the opposite operation, right? So I'm going to be left with 4k equals minus 16. This will be minus 40. And then 4k equals negative 16 minus 40 would be negative 56. And then all I'm left there is my last step is I have to divide both sides by 4, right? So if I'm dividing both sides by 4, I would get k equals negative 56 divided by 4. K here equals negative 14. And that will be my answer for number 25. K equals negative 14. So there you have it. That's going to be my answer for 25. So again, these were the easy rational equations. Now let's move on to some harder problems. So this is the second worksheet. So these are some harder problems. So it says solve each equation. So the difference between this part 2 and part 1 is that we had well, in part 2, you see here I have variables on both sides, and then in this case what happens was if I gather like terms, I would usually get variables on one side. So let me try some of these ones. So let me try every other one on this left side, and these ones will look a little bit harder, right? So let's try every other one on the left side here. So this is this question 1, and then what question 1 is asking is that we have square root of 110 minus n equals n, right? So this here is the square root of 110 minus n equals n. So again, to how will we approach this problem? First, we would have to do the opposite sign, right? The opposite sign of the square root is squared, right? So let's do that. So I have 110 minus n squared equals, and if I square this side, right? So in this case, it's just n squared because it's just one thing squared, right? The square root and the exponent cancels out on this side, so we have 110 minus n equals n squared. And then what we're doing here now is that we are solving for, again, we're solving for n, right, in this case. So I want, let's move n to the other side. We want to move n to this right side here. So we have 110 equals n squared. We're adding both sides, right, by n. So we have plus n. And then now we have something that's kind of weird, right? We have here 110 equals n, n squared plus n. So how will we solve for this problem? My variables are already on this side, but my constants are on this side already. So how would I solve for this equation? So what I'm going to do is I'm going to do something called common factoring. And what that is if I see something that's common between two variables, I can take it out. So in this case, I have n here and n here. So I can take out this n in this case. I'm going to create a bracket. So if I take out this n here, I'm left with n. I'm left here with n. I'm left here with n, and then this is plus 1. And that's how I would common factor this. But I don't know if that would help me if I would factor this problem here. Let me just think about this for a second. I don't think it would help me in this case. So let me just check what we're doing here. So I'm going back and I'm removing the square root, so that's the square on both sides, which is awesome. I have 110 minus n equals n squared. And then I'm moving n to the other side, so that makes it positive, which is great. And then I'm trying to factor here. But factoring doesn't really help me in this case. So I'm trying to work backwards. How would I solve for this problem here? So I'm not going to factor in this case. But let me think about this problem for a sec. 110 equals n squared plus n. Plus n here. If I were to factor, I would still only get n here and n plus 1, and that doesn't really help me in this case. Yeah, I don't think that helps me in this case. Because I could move n to the other side and divide both sides by, I would have 110 over n equals, this would be just simply n plus 1, right? But that doesn't really help me in this case. Yeah, this doesn't really help me. So let's see. I could do something called a guess and check, and that's how I would solve for this problem. And what I mean by guess and check is that I would have to have something like this. So if I have 110 here equals n squared plus n, I know n has to be the same number, right? N here has to be the same number. And what I'm going to do is I'm going to see, it's going to be something squared plus that same number, right? So for example, I would do a guess and check. So for example, if I were guess, let me say 110, let me guess what's 9 squared in this case would equal 81. 10 squared equals 100, right? So 9 times 9 is 81. 10 times 10 is 100. I'm picking a number that's close to this number here in this case. And then if I did 11 squared, it would be 11 times 11 is 121, right? So in this case, 10 squared would probably be the closest to 110. So and basically what I'm doing is I'm guessing that n here equals 10 to solve for my equation here. So if I guess n equals 10, then I would be able to solve for my problem. So I would have 110 equals, and then if n equals 10, I have 10 squared plus 10, which is 10 squared here is 100 plus 10, which is 110 equals 110. So that actually gives me my correct answer. So in this case, n would here, this is a guess and check, n equals 10, but I don't know if we could solve this equation knowing what we know in Algebra 1. Just because we have to do something that's called, in this problem, we would have to do something called the quadratic formula, and I don't think we learned about that yet. But what that means is if I were to do this algebraically, I'm trying to get into the mindset of Algebra 1 here, and I don't know if you do quadratic formula. I would have to check the curriculum, so just give me a second actually. So maybe you do it. So you do quadratic functions much later on, actually. So you do this, of course, but you don't know it in this one-step equation. So if I were to do the quadratic equation, I guess I'll do a sneak preview because that's what we're doing here in this case. So basically, what that means is I have what a quadratic equation is I have something that's squared, and then I want to solve for this this variable. So how I would solve for this is I would actually move 110 to the right side as well. So I would have 0 on one side equals n squared plus n minus 110. And then I would plug in something called the quadratic formula. So I'll write down this formula for you. You don't really have to know this until much later in the course, but this is a negative b plus minus the square root of b squared minus 4ac all over 2a, where this here is a, this here is b, and this here is c, right? So we're just simply following this equation. So if I were to solve it, I would have like negative 1 here. This is imaginary 1 plus minus square root of b squared is 1 squared minus 4 times a, which is 1. C here's negative 110 all over 2 times 1, right? And that's what this problem does. And if you actually work this out, I'm lazy, so I'm just going to simply give you a calculator answer here. So let me just do that for you. So this is 1, 1, and negative 110. You're going to get here, it's negative 10 or negative 11 would be your answer. So in this case here, n has two solutions, so it would be 10 or negative 11. And what I would have to do is I would have to plug these two answers back into my equation here, right? So if I were to check, and so remember my answer from my the calculator was a 10 or negative 11, right? Let me just check. This is 10 or negative 11. Good. It's 10 or negative 11, and then what I would have to do is I would have to check my answer based off these answers here. So this would be 110 equals n. I would assume that's because I knew I have here 10. I already knew n equals 10 is my answer, right? So let's check negative 11. So this is negative 11 squared plus 11, right? So I have 110 equals negative 11 squared is 121 plus 11. 110 equals 121 plus 11 here is 132. So this is a wrong answer, which means I can negate this answer, which means n equals 10 is my answer for this problem. So again, this is a much harder way to do this problem here. We're making kind of a big fuss about this this quadratic here, but I don't see another way to do this problem besides that, because I would have n squared plus n if I were to factor n squared, and I'm making a big deal about this problem because it might affect us in the future problems, right? So we had here 110 as n squared plus n, right? So what my first approach was I tried to factor n here, and in this case, right? I tried to factor this. I would have n times n plus 1 in this case, and this is when like I can't do much with this problem here, because I'm left with I'm left here with two variables that I can't be like, oh, n equals 110, split this up into two specific problems. So in this case, I can't really solve for this problem here, which is unfortunate without doing the quadratic formula in this case. So again, we got the answer eventually. It's just I had to imply something that's new, a new concept for some of you that might not know this concept already. So let me do number 3, and I'm hoping that these problems don't have the same concept, but if they do, then I would have to do the same thing. Actually, no, I'm doing every other one. So let's do 5 here. 5 here is x equals the square root of 42 minus x. So again, take a moment first and let's see how would you solve this equation. So take a moment and do that first. Yeah, so take a moment and do that, and then we'll take it up together. I'm just gonna check something while we wait here. So how would we approach this problem first? What are we doing first? So let's do this problem. So again, what we're doing first is we are going to do eliminate the square root, right? And that's what we've been doing in the past. So let's eliminate the square root by taking the square root of both sides. So I would have here, in this case, I would have x, this be squared equals, and then I would have 42 minus x squared, right? And the square root and the squared cancel out. So I'm left with x squared equals 42 minus x. So I'm already seeing here we have the same problem. We have the exact same problem as our previous question here. So I guess what we're going to have to do is we're just going to have to deal with, and again, I know why this is a harder problem now, and the only reason why it's a harder problem is because we're using a quadratic formula, we're using we're using factoring to solve for these problems. So let me see if I can factor this actually. I'm pretty sure I can factor this. So I'm gonna move x to the left side here. So I have x squared. This would be plus 6 equals 42. And again, we can't really do much with this problem. But what I can do is I'm going to put x squared plus x, and then I'm going to put 42 also on the side. So this would be minus 42 equals 0. So again, what I'm going to do is I'm going to employ another kind of not solution, but another concept called factoring by inspection. And what that is every time I have x squared plus something plus x minus some sort of constant, I could factor this into two different things. And how I would do that is I can I'm going to tell you the answer first, and then what I'll do is I'll show you how I got this problem. So again, I would have, actually no, let me just work this with you because I think it's a lot easier because we're looking at this for the first time. So how I would factor something is I would have to do, and we'll do this later, I promise, we'll do this later. But I'm going to have to take this a value, which is an imaginary 1. I'm going to multiply it by this c value. So this is a, b, and c. So I'm going to take a times c, which is 1 times negative 42. So the product is negative 42 in this case, and it'll have to sum to b. So I'll have to sum here to positive 1. So I'm thinking of two numbers that would multiply to negative 42 that would add to 1. So what two numbers would they be? So my factors of negative 42 have 1. I think 3 is divisible, 6, 7, and I think that's about it that I can think about. Maybe, I think 1, 2, 3, or 1, 2, 3, 6, 7, right? And I know that 6 times 7 is 42. So maybe I'll use, and it has to sum to 1, right? So in this case, let's do I'm doing 7 times negative 6, because 7 times negative 6 equals 42. 7 plus negative 6 equals positive 1, right? So in this case, this works. So 7 and negative 6 are my factors. So what I'm going to do is I'm going to have to split b into two numbers. I'm going to do x squared. I'm splitting this into plus 7x minus 7x minus 42 equals 0. And I can do that because 7x minus 6x equals 1x, right? I'm just simply rewriting this x in terms of two things that also equal x. So 7 and negative 6 in this case. And now what I can do is I can I see 4 terms here. I'm going to take I'm going to do these 2 terms and these 2 terms, sorry, and these 2 terms together. I'm going to do the same thing as I'm factoring, right? I have x squared and plus 7x. The like term in this case is x, or the common factor is x here, which means I have x left here, and then 7x divided by x is simply just 7, so positive 7. And then I have negative 6x minus 42. The common factor in this case is negative 6, right? Because I can divide both sides by negative 6. So I will take out negative 6 in this case. Negative 6x divided by negative 6 is simply just x. Negative 42 divided by negative x is positive 7 equals 0, right? And then what I can do is I can see that I have a common factor of x plus 7. So I can take out x plus 7 in this case. So I'm taking x plus 7. I'm left with x here and x minus 6. So I'm left here with x minus 6 equals 0. So now what I can do is I can actually I can solve this equation now. And how I can solve for this equation is I can break them up, because and the reason why I can do this is that this equals 0. And how I'd break this up is I would do case 1 and case 2. Because what we know is anything times 0 equals 0, right? So which means one of these guys, one of these guys has to equal 0 in some way. So I'm going to do, this is case 1. So this is x plus 7. I'm going to set it to 0. X plus 7 equals 0, right? Which means if I move 7 to the other side, it would be negative 7. So my first answer is negative 7. And then I have x minus 6 equals 0. I'm setting this one to 0 as well. If I move negative 6 to the side, I'm going to get positive 6. So x plus equals positive 6 is my other answer. However, I have to check if these are answers. I'm checking for this term extraneous solutions, means that some of these solutions algebraically might work, but in my equation it won't work, right? So we have to check for this is extraneous solutions. And that's what I'm doing with this negative 7 and positive 6, right? So maybe I'm going to go back to my equation, my first equation here, which is this, right? Or actually, I could just do, maybe I'll use this. X equals, this is a positive 42 minus x, right? So I'm checking, let me check for extraneous solutions. So let me check negative 7 first. So if x was negative 7, so I'm rewriting this problem. This is x equals square root of 42 minus x, right? So in this case, x here is negative 7. So I would sub in negative 7 for both sides. So it'd be 42 minus, this is minus 7. Negative 7 equals, so the bracket 42 minus 7 is 49. And the square root of 49 here is positive 7. I have negative 7 equals positive 7. This answer is not correct. So negative 7 is not one of my solutions. So let me check here. Let me do a little column here and check x equals 6. So this is so this is not correct. And I'm going to do this one. And this sub in now is 6 here. So 6, so I have x equals square root of 42 minus x. I'm going to sub in 6 here. So 6 equals 42 minus 6. I have 42 minus 6 here is 36. Square root of 36 in this case is indeed 6. So this actually works out, which means x equals 6 is my answer for this problem. So this here verifies that this solution is correct. So x equals 6 is my solution here. So again, with these quadratic equations, ideally when we're working on these solutions is actually way later. But I guess we're introducing this concept now, so you're more familiar with this in the future. So that's what I'm hoping that we're doing here. We probably only have time for one more problem, so let me pick a harder one to end off. Let's do 23 here. 23 looks kind of fun. 23, I have 4 plus, and this is the square root of this is the square root of negative 3m plus 10 equals m, right? So again, what we're going to have to do first, so your first instinct was like, oh, maybe let's get rid of the square root. Actually, no. The first thing we have to do is we have to get rid of this positive 4, right? And then we can get rid of the square root. Remember, the opposite opposite rule of PEMDAS is subtraction first. So let's, or addition first. So let's subtract both sides by 4. So I'm left with here is negative 3m plus 10 is m subtract my m minus 4, right? So that's cool. That's nice. And then what we can do is we get rid of the square root, right? So I would have to square both sides. 3m plus 10, squaring both sides, so m minus 4, and this is squared for both these terms, right? So it's both these terms here, so just be careful of that. I can see why this is a harder problem now. So I know that square root and squared cancel out, so I'm left with negative 3m plus 10 equals, and this is m minus 4 squared, right? So that's cool, but and now it's like, okay, so what I could do is I could get rid of the square by square rooting, but we're just gonna go back to this first initial step, so we can't do that. But what I can do is I can do something called expansion. I can expand this exponent, and what I mean by that is I'll write it out here. So this is negative 3m plus 10 equals, I can write m minus 4 times m minus 4 out, right? And what we're going to employ here is it's this kind of this a rule to distributive property that we haven't talked about. This is the concept of FOIL, and FOIL means front, outside, inside, and last. And what that is it helps us expand two binomials, or two two-termed terms, if that makes any sense here. And how I would do that is I would have to take m times m first. I would do this function here first. So this is first, which is m times m here is m squared, and then I would do outside. So I would take m and then I would times it by this term here. So this is outside. So m times negative 4 is negative 4m. I would do I, which is inside. So negative 4 times m here is minus 4m again. And then last is this last term here. So negative 4 times negative 4 is positive 16. So what I can do now is I can collect like terms. I have here a negative 4m minus 4m, right? So let me rewrite this. I have negative 3m plus 10 equals, I have m squared. Negative 4m minus 4m is negative 8m plus 16. And now I see a lot of like terms we can combine. So let's do that. So I have negative 3m and negative 8m, but then I also have plus 10 and plus 16, right? So let me group those together. So I'm going to put all the variables on one side again. So I'm going to add 3m to both sides, right? So I'm left with, this is just simply 10 equals m squared. So I have negative 8m plus 3m plus 16, right? So I have 10 equals m squared. I'm gathering these two like terms. Negative 8 plus 3 is negative 5m plus 16. And then what I can do is I'm going to bring this 10 over to also the right side, right? Because I realize I have a quadratic equation again. So I'm going to subtract both sides by 10. So this I'm left with 0 on this side, and I'm subtracting both sides by 10. So this is plus 16 minus 10. And then I have 0 equals m squared minus 5m plus 16 minus 10 is negative 6. So again, what I'm gonna have to do is I'm gonna have to do my exact same thing here. I'm gonna have to factor this to get our answer. I'm factoring our quadratic equation in this case. So this is this 23, right? So can I factor actually? I'm not sure. Let's see. This might be factorable. So this is the product of a and c. So this is 1 and 6, which is negative 6. It has to add to negative 5, right? So my factors of negative 6 are, let me write down here, factors. Negative 6 would be 1, 2, and 3, and 6, obviously. I need something that equals negative 5. So I'm picking negative 6 and positive 1 would get me, because negative 6 times 1 is negative 6, and negative 6 plus 1 would be negative 5. So those are my two factors, which means I can separate this term into two terms, right? I'm doing 0 equals m squared. I'm doing negative 6m plus m minus 6. And then what I can do is I can factor this part out and this part out, right? So I'm left here, m is, I can divide both sides by, two terms by m. I'm left with m minus 6 in this case. And then I have nothing that's common, but I can factor out this imaginary 1 here, right? This would be m minus 6 as well. I can take out m minus 6 and have m plus 1 here. And again, don't worry about what we're doing here, right? This is just, again, a sneak peek of what I'm doing probably in a later video here. And this equals 0, right? And then I can do both my cases where either one could be 0. So I have m minus 6 equals 0 and m plus 1 equals 0. I can move this to the other side, it would be m equals positive 6. If I move positive 1 to the other side, I get negative 1, right? So these two are my answers, but I have to check in my first equation whether or not this works, right? So let me just do a check, and that will be my final answer for this problem. Kind of running out of time here, but this is 23. So I'm going to rewrite, this is 4. I'm checking the first one here. I'm doing positive 6 here. So it's 4 plus square root of negative 3 times 6 plus, negative 6 plus 10 equals m. So 4 plus negative 3 plus 8 here is negative 18 plus 10 equals m here is 6. 4 plus negative 18 plus 8 plus 10 here is negative 8 equals 6. So I can't take a square root of a negative number. This will give me a complex number, which we don't talk about in this course. So so in this case, this will never be an answer. So let me check negative 1. If you type in a negative square root, you're going to realize that you get the same problem as well. So this is 4 plus square root of negative 3 times this negative 1 plus 10 equals negative 1, right? So I have 4 plus square root of negative 3 times negative 1. Here is positive 3 plus 10 equals negative 1. I have 4 plus, this is 13 equals negative 1. Square root of 13 plus 4 is not 1, which means I have no solution in this one as well, which means, unfortunately, for our problem, and this is number 23, right? For 23, I checked both my solutions, and they're both incorrect, which means in this problem, I have no solutions. No solutions, which is super unfortunate for our last problem of the day. So I hope you learned something about radical equations. I know we did kind of get into depth into what a quadratic equation is, and we'll talk about that more further in the course. But I hope you understand kind of radical equations more as we move along. Again, the only thing we're doing with radical expressions is this step here. The most important thing was this step here, right? To get rid of the square root, you have to square both sides, and that's kind of the takeaway for today. So for our next lesson, what we're going to do is we're going to solve rational equations, and then again, obviously, we have harder rational equations we can solve as well. So hopefully, stay tuned for that, and as always, have a great day.